apologies, I had to cut that video short. My mom, she came over, and don't mess with mama. That's all I gotta say. So I texted her and said I'm making a video here, but she said she just didn't care. So anyway, 3 coffees later, here we are. Just continuing on here with what we are looking at. We were looking at Z is equal to positive 2.55 standard deviations away from the mean. Remember there, where we calculate the Z table here, goes from 0% all the way up to 0.5. I think it was 0.4999, right? So it only deals with half. So we're only counting from the mean, which is 0 here. So we're looking for this area under the curve, right, at 2.55, right? 1 standard deviation, 2 standard deviations, and then 5.55 is in here somewhere. So we're looking at 34 plus 44, so we're looking at somewhere around 48 or 49%-ish. All right, so let's have a look here. Where are we here? Move that out of the way. 2.55, zoom in. Right, 2.5, 1, 2, 3, 4, 5. So as we said right there, we were right. That's 49.46%. That area right there, right? So that's how you use the, we're going to practice calculating Z, okay? Applying the Z, using the Z table, find the probabilities under here. Have a look at the assignment. I asked, there's a couple of questions on there exactly like what we were just doing. Okay, these guys right here, finding the area under the curve. Okay, like for these ones here, how would you calculate the area under the curve using the Z's here? Right, you've got 2 Z's in this fact. Well, in this case here, you would have to calculate the area here, right, because you remember there that these arrows, I'll just steal an arrow from over here, right? And you remember there that these arrows, right, they calculate this area here, right, starting from the mean. Well, this area here is on the other side, so what are you going to do? You got to have to do 2 Z table checks, because then once you have that Z number that you just found on the Z table, then you have to calculate what this value is. So you have to go back to the Z table, check out the Z value for here, and then you would add these 2 Z values together, and then you would get your probability. Okay? These ones here, how would you do these ones? Just flipping this around here, right? You have 2 Z's again, so you'd have to find the value for Z2 on the probability table, write it down, and then find the value for Z1 on the probability table, and then subtract 2 from 1, and you will get that area there. So let me know if you guys have any issues with that. Lots of fun there. Next week there, week 13, I won't leave you hanging. I've got a review PowerPoint that I'll probably post there this week anyway. Just to, I'll give you guys everything there that I have. Okay? And lots of practice and lots of good stuff. All right, moving on. Here we're getting into the whole idea of comparing apples and oranges. All right? And why is standardizing different populations important? For one reason, so you can compare these different populations. And what do I mean, different populations? Well, normal distributions do not necessarily all have the same mean, right? Of course they don't. Here we're talking about the number of apples eaten per day, and then this study here, the number of oranges eaten per day. They ain't going to be the same, right? So different populations will have different means as well as different standard deviations. So standardizing a population with a mean of 0 and a standard deviation of 1 is called the standard normal distribution. Okay? And so what you're doing is, I'm just looking for this graph, one graph in particular. Yeah. Here I've got these 2 graphs here that have 2 different standard deviations, same mean. here I have these two graphs here with different means, the same standard deviation. Here I have two graphs here, two populations here with different means and different standard deviations. In all cases, you can't compare them, okay, because they're not standardized. And what you're doing, the whole point of Z-score and standardizing, is you're taking one graph with its own parameters, mean and standard deviation, and you're taking another graph with a different mean and a different standard deviation, and you're standardizing them so that they both have the same mean, 0, and they both have standard deviation of 1, 2, 3. That's the whole point, is you're taking two different populations that you previously could not look at. You couldn't examine them, you couldn't compare them because they have different means, different standard deviations. I don't even know what's going on. But if you take these guys and transform them into the standard normal curve, okay, with a mean of 0, 1, 2, 3, right? Now you can actually compare apples and oranges, right? So normal distributions don't always have the same mean or standard deviation. So standardizing a population with a mean of 0 and standard deviation of 1 is called the standard normal distribution. And just can coincide with our apples and oranges theme here. There we go. I want to zoom in. Thank you. So you see here I have the number of apples eaten per day. Whatever, it doesn't matter, you know what I mean? And for some strange population there, the number of apples eaten per day, the mean is 68 apples. It's a lot of apples. Yeah. So here you've got this population here with a standard deviation, with a mean of 68. And what's the standard deviation in this case here? You can calculate the standard deviation. The standard deviation is 9. And then another 9, 77 to 86, and then another 9. Right? So the standard deviation in this case is 9. The mean is 68. Okay, great study. Love it. Number of oranges eaten. In this particular study here, the number of oranges, maybe this is annually. Let's look at annually, right? This is not daily. So the number of oranges eaten annually by a particular population, the mean here is 1,010 oranges eaten annually. Okay? And what's the standard deviation here? Well, 110 to 130, so that's 20. And then another 20 is 50, another 20 is 70. So in this case here, the standard deviation is 20. The mean is 1,010. Here, the mean is 68, and the standard deviation is 9. Can't compare apples and oranges unless you standardize this one here and put it into this form. There's your 0, 1, 2, 3 as we've seen. And you take this one here and you can standardize it into the same form so that they both have the same mean, 0, and they all have the same standard deviations, 1, 2, and 3. And it is at this point, once you've standardized this one and standardized this one, transform them both into the normal curve, okay, now you can analyze them, okay. So the whole point here, there's your Z, coming back to this slide here, okay. This is to calculate your Z-score, which is just a way of counting standard deviations. So if you get a Z-score of positive 1.5, that means there you're 1.5 standard deviations in the right direction. If you get a negative 2 as a Z-score, that means there you're going to be 2 standard deviations in the left direction. Let's go. So here I've got again, another fictitious example here, changing raw data into Z-scores. So we're just that same, you know, what was that, 1,010 oranges, or was that, yeah, oranges annually are eaten by a particular population. So it was determined that the average total, and here, I just made this up again as well. I take the same one here. I think this one is about brushing teeth, but we're using the same diagram here. It was determined that the average total time spent brushing our teeth was 1,010 hours over the course of our lives. Completely made up. Assume the standard deviation is 20 hours. Well, it is, right? 110 to 130 to 150. You can see it's 20. Standard deviation is 20, okay, with a mean of 1,010. Compare the Z-scores of 1,041 hours, 977 hours, and 957 hours using the Z table provided. So basically what we're doing is there are 3 people of interest that I want to examine under this population. And one person, like the average number of hours brushing your teeth was 1,010 hours. Well, this person here did 1,041 hours. Well, this person here is less than the average, 977 hours, and this one here is even more so. So, and what I've done here is there's your 1,041, 977, 957. Those are those numbers right there, and I've color-coded them, okay? And where they would appear on our graph. So this is a graph here. This is not standardized, okay? This is just the graph with the data. There's your mean. There's your standard deviation of 20. And you'll see there 1,041. Where's 1,041? There's 1,050, 1,030. So 1,041 is right in around here where the yellow dot is. 977, blue. 977, somewhere in here, right? There you go. Let's just move it right there. 977. And then we've got 957, which is in here somewhere. So you see, that's where these dots are on our graph there that we just did this study on you know how long people brush their teeth for. Standardizing this, not a problem at all. It's easy peasy. And we just want to show you there with the yellow dot here, right? I want to standardize this, and I want to change this so that I can compare this against people who brush their hair. Right? Brushing hair, brushing teeth, different means, different standard deviations, doesn't matter. Because once it's been standardized, you can compare it against anything. Okay? So, you have a look here. We're just going to do the yellow one as an example. There's your 1,041 hours, right? We know where that one is, right? That's your 1,041 hours. You can see 1030, 1050. It's right in the middle. So, use your Z formula, which was that one. Z is equal to X minus the mean divided by standard deviation. So here's your example. Z is equal to X, 1,041, minus the mean, 1010, which was given, divided by 20, which is the standard deviation, gives us a Z score of positive 1.55. Now it's positive, that means it's in the positive direction. It's negative, it'll be in the negative half. But since this is positive, right, 1.55 standard deviations away from the mean. So, now you can go 1.55, there's your 55, and you can put your yellow dot, and it will be exactly the same spot. So you didn't change anything. You're really not changing anything according to the data. You're just standardizing it with a mean of 0 and constant standard deviations for the whole point of analysis against something else with a different mean and different standard deviation. So the whole idea here is that your Z value of 1.55, and you'll see it's in the same spot, and 1 standard deviation, 2, it's not 2, it's in the middle, 1.55. Now you can calculate your probability of the area under the curve. Now remember, the Z table only measures from 0 outward. So basically, the area under the curve, all of here, what do you think your percentage will be? Well, this one right here is 34. This one here is what, 17. So, we're in and around, that range. Let's have a look here. Positive 1.55. Positive 1.55. 1.1. 1.1. 1.55. 1.5. 1.55 is 43.94. 0.4394. 0.4394. So what do we got here now? That is 0.4394. So that is that's the probability, right? Probability equals. All right. So that is what we're looking at. That's the probability. And that's about where we were. 34 plus 17, you're in that range. Okay. 40 some odd percent. And that's what we expect. And I am confident that that answer is good. Okay. So the whole idea of being able to change a real data point into a normal distribution, okay, that's what we want to be able to do. And you'll see you're not changing anything. You will see there that the purple dot 977, okay, it has a standard deviation, okay, of negative 1.65. You can do the mathematics. You will see there that 977, you plug it into the Z formula, you get a Z value of negative 1.65. Well, negative 1.65 is right there, which looks exactly like that one. 957 hours brushing your teeth, that corresponds to a Z value of negative 2.65, okay, and negative 2.65, you'll see it's in the same spot. And we didn't calculate the probabilities under the curve for these guys here, but you have the Z values, you can find them under here. Just remember, these are negative. There are no negatives on here. Just flip these there to a positive and find the corresponding Z values on here and their probabilities. And they should come in pretty close to what you're thinking. Okay? Here's an example. Little Johnny ate 9.5 hot dogs at the Dobson family reunion in 1965. If the mean number of hot dogs eaten at the reunion was 3.5 with a standard deviation of 3.01, analyze his results in comparison to other participants by performing a Z-score. All right, pretty silly question, but you can see the relevance here. This kid ate 9.5 hot dogs there, while the majority of people only ate 3.5. There's your mean, standard deviation of 3.01. So plug in your numbers there, find your Z-score, because I want to find the probability to compare it against everybody else. Z is equal to x minus mean divided by standard deviation. Z is equal to 9.5 minus 3.5 divided by 3.01. Gives us a Z-score of plus 1.99. Remember, that's standard deviation. So, and because we're plus, we're on the right side of the graph, not the left. So you see here, okay, same, you know, we're dealing with little Johnny here in the hot dog situation. So Z-score gives you, get Z-score given, you find there the probability. So what we've got going on here was there's your Z-score of plus 1.99. So going back into our, I just wanted to show you guys right here where, oh no, of course I can't find it. Yeah, oh, that's the one I wanted right there. There it is. So you have a look here. Find the area to the left of 1.99. So I've got, there's my mean of 0, mean of standard deviation of 1, standard deviation of 2. So basically we want to find all the area under the curve right here. First and second standard deviation. Remember, it's plus 1.99, so we're going in this direction. I want to find this area here. So now what we do is, and I've kind of got the arrows all lined up here for you. Okay, we want to find a Z-score of 1.99. Okay, so now let's have a look. Sorry, I'll bring this there to the front. You'll see there 1.9, and then 1.99 is 0.4767, so that's 47%. 47.67%. Okay. Now remember, this is where little Johnny is. Dude ate 9.5 hot dogs. Everyone else ate 3.5. This is where little Johnny is in comparison to everybody else. So where is little Johnny? Well, this is 47.67%. We already saw that, right? We calculated. But this area here, that's 50%. We know that. So little Johnny is in the top 97 percentile of eating hot dogs at his family reunion. Okay, so you find the z-score, 1.9 row, and go over to 0.09 column, and there's the number there that we found. Okay, so that remember the z-score measures from the zero mean to the z-score itself, and that's your probability. That's your area under the curve. So the area there is 0.5. You can't exclude that, because you need to add up both of these there. So the total area under the curve in this case here is 97.67%. So little Johnny scored in the top 97% of all eaters at his family reunion. Okay, good little question. Not too bad. Let me know if you guys have any issues on that one. It's a nice one. Area under the curve, again, probability. Find the area to the right of z is equal to negative 1.16. So we're looking for the area to the right of that z-score. What is the probability? Remember, your z-score table will measure from here to here. This side here is all 50%. So whatever this side is, you're going to have to add 50% to this one. Okay, so a z-score of 1.16, because we do not measure the negative, 1.16, so is 37.7%. 37.7% plus 50%. The total area under the curve to the right of z is equal to negative 1.16 is 87.7%. Try another one. This one here, probability again. Find the probability where in between 0, so z is in between 0 and positive 2.32. So between 0 and here. So you find the z-score on the z-score table, positive 2.32, 2.32, which is 48.98 if my eyes are all right. So in this case here, we're not worried about this 50% in this case. So in this case, do not add 50%. We're only interested in specific parameters. Find the area, the probability for here. It has nothing to do with the left side. So in this case here, we're looking at 48, almost 49% of the data is included here. Okay, with a z-score of 2.32. Another one here, you'll see here I have two z-scores. Here I have a negative and a positive, and I want to figure out the area, the probability under the curve here, okay, for the two specific areas. So in this case here, you would have to do two z-table checks, right? Because the z-table only starts from 0 out, so you'd have to find the probability for that z-score, write it down, and then using this z-score, 1.68, find the probability, write it down, add the two numbers together, and you'll find the area. Okay, and negative 1.37, 1.37, so 41.47. Okay, there's your 41.4, your 0.4147, and then for a z-score of 1.68. 1.68, 45.35, 45.35, you add them together. So the total area under the curve for these two Z values there is 86.82%. All right. Here's some more for you guys to try. Find the probabilities. You know, this is the probability there of Z there between 0 and 2.6. You know what I mean? Have some fun with these. The answers are all here. Okay? Let me know if there's any issues. Okay? Some more try questions here. What is the probability of scores between the mean and a z-score of 0.4? So in this case here, I just want to show you there that I don't need to show you a graph here. You should be able to, quick like a bunny, do a graph. Okay? So what is the probability of scores between the mean and a z-score of plus 0.4? So in that case here, what are we looking at? Bring to front. So you'll see here that you look at this example right here. We want a z-score of 0.4. So a z-score of 0.4 would be right about here. So I want to know what the area under the curve is for this area, right? Answers are all there. Have a look at them, you know, the whole idea. There's your z-score. Look under your table right here. Have some fun with these, and it really helps to be able to do a quick little draw. You know what I mean? Your mean of 0, standard deviation, second, third. You know your percentages, 34, 17, 2.5, these kinds of things. So you should be able to spin off a little diagram in like 3 seconds. It totally helps, okay? Just for understanding. Some questions here. This is where we will kind of conclude. There's the last couple slides here. They're on questions. And these are good ones here, okay? But before we do that what about working in reverse? What about finding the z value from the probability? And in this case here, you got to work backwards. Not a big deal. But find the z value such that the area under the standard normal curve is 0.2123. So probability of 21.23%. So you find 21.23 or the closest to it, and then backtrack. There's your 0.06 plus 0.5. So therefore the z value that corresponds to a probability of 21.23% is 0.5. So in that case there, that z value is 0.56. Sorry, I don't know if I said something else there. The z-score there, 0.56, positive. So, and you'll see there that your area under the curve, your probability is 21.23% in here. Okay, so I may ask you to backtrack. Again, here are more z-value problems there for you to have some fun with. Okay, let me know if you have any trouble. Okay, this is a good little question here. Welcome to it. A survey by the National Retail Federation found that women spent on average $146.21 during the holidays. I don't know, man, what was this, the 1800s? That doesn't sound like very much anymore. That's almost like a couple days worth of groceries there these days. Assume the standard deviation is 29.44. So that is your mean. That is your standard deviation. And find the percentage of women who spend less than 160. Assume the variable is normally distributed. So I always recommend you kind of draw this thing out. Okay, there's your mean, 146.21, right? There's your standard deviation, 1, 1, 2, 2, 3, 3, you know. And, you know, remember you're going to have like almost, you're going to have two numbering systems. 0, 1, 2, 3, right? 0, 1, 2, 3 kind of a thing. Okay. And then you're going to have your mean is 0, standard deviation 1, standard deviation 2, standard deviation 3 kind of a thing here. So let's have a look. Here is our mean, $146.21, as given by the question. Standard deviation, okay, is 29.44. So if you add 29.44, add 29.44, add 29.44, subtract 29.44, subtract, that's where you get those numbers from. Okay. Now, our number there, the question is asking, find the percentage or find the probability of women who spend less than $160 at Christmas. Okay? Or the holidays. So here's 160, and I want all of these women. I want them all. Okay? And I want their percentages. What percentage of women spent less than $160 over the holidays? So what do you think here? You got to have a little bit of an educated guess. Well, we know what this side is, right? That's going to be 50%. We're at least 50%. And now Well, there's the first standard deviation, so that's 34. So I don't know, what would you say? It's around 20, give or take. So 50 plus 20. So our answer should be in and around 70% of the women spent less than 160. That's what we're shooting for. That's what's going to make sense. So somewhere around 70. So let's go. So find the Z value corresponding to $160, right? Remember that Z value? Okay. What Z value corresponds to 160? Remember your formula, x minus mu divided by standard deviation, 160 minus 146.21. That's the mean divided by 29.4. Standard deviation gives you a Z value of plus 0.47. Go to your table. Z value plus 0.47. 0.47, that's 18.08. So that means there that that value, that distance from the zero line to that Z value is 0.1808. The question was asking all women less than $160, so I have to add that my 50% in there. You'll notice there that we generally deal with 4 decimal places. Well, okay, when we're talking percentages here, that's just the way it is. So the area here, 18% plus 50%. So that means there that 68% of the women spent less than $160. Okay, 68%. You remember we were looking for somewhere around 70. Bingo. Good answer. Okay. Let's try another one here. Newspaper recycling. Each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the standard deviation is 2 pounds. Okay, the mean is 28 pounds. If a household is selected at random, find the probability of it generating between 27 and 31 pounds per month. Assume the variable is approximately normally distributed. So again, draw it out. So, hey, the curve, boom, done. The mean, 28, okay. The standard deviation would be 30, 32, 34, right? Because the standard deviation is 2 pounds. The standard deviation going left would be 28 minus 2 is 26, 24, 22, all right? Now you can draw in what you're looking for. We're looking for households there that are produce 27 to 31 pounds. Okay, so you'll see there's your mean. So 27 is over on the negative side. 31 pounds is on the positive side, right? Okay, and you just have a look at where your standard deviations are. Kind of have a guess, right, of where we are at. Of course, it's just approximate. We'll do the actual math in a little bit. You'll see there. So, and what are you thinking here as far as a guesstimate? Well, there's 34%. Now this whole area is 17, but maybe we've only got a fraction, so maybe 10%. So 34 plus 10 is 44. Maybe this is another 10, 12%, so 54, 55. I don't know, somewhere in there. And draw the normal distribution curve. What percentage do you think? Guess. And I came in and around 59%. We have 34, 10, 10, somewhere in that range. Okay, it's not 20%, right? You've got to be able to see. You've got to be able to kind of guess how much it is. It'll ensure there a high mark. Okay. So now this is what we want. There's the same graph. There's the mean 28 pounds. We want to know what probability or percentage of households there can produce between 27 and 31 pounds. So you have two values here, so you got to have 2 Z's. So 27 minus the mean divided by the standard deviation gives us a Z value of negative 0.5. And that makes sense because this is in the negative region. And then 31, Z is equal to 31 pounds minus 28 pounds mean divided by 2 pound standard deviation gives us a Z score of positive 1.5, which makes sense because it's on the right-hand side. Now find the areas between each, right? Because using this table, I'm able to measure that distance, and then I have to do another Z, and I measures out again, right? So here are my two values. Let's have a look at them right here. Here I have a Z score of negative 0.5, which is 0.5. So I got 19.15%. You'll see it right there. And then the right side here, I got a Z score of 1.5, positive 1.5, 1.5, 43.32% right there. And then you just add these two guys up and you get a value there of 62%, which I think was close. Didn't we say 59? And around. Okay, that's how we do those. And this is the last slide here. All right. Emergency response. Okay, the American Automobile Association reports that the average time to respond to an emergency call is 25 minutes. There's your mean. Assume the variable is approximately normally distributed and the standard deviation is 4.5 minutes. Okay. If 80 calls are randomly selected, approximately how many will be how many calls will be responded to in less than 15 minutes? Okay, so there's our mean. There's our standard deviation. Okay, and we've got 80 calls here, and this is all in minutes, right? So we want to know if 80 calls are randomly selected, approximately how many will be responded to in less than 15 minutes. Okay, because the mean average time is 25. Okay, deviation 4.5 minutes. Okay, so what do we've got going on here? There is your mean, 25 minutes. And we want to know if 80 calls, okay, how many will be responded to in less than 15 minutes. So there's your 15 minutes right there. So we're dealing with the smaller, right? We want to know how many calls will be responded to in less than 15 minutes. So that means all of this area, I need to know this probability. Okay, so now 15 minutes, there's your Z. We need to figure out Z. So 15 minus the mean divided by standard deviation gives us a Z score of negative 2.22, which makes sense because we're in the negative side. All right, so in this case here, so 2.22. Let's see what the probability is here. 2.22 gives us a value of 0.4868. 0.4868. So that is from the zero line to that Z score, 0.4868. That gives, I'm not interested in that space. I'm interested in that space. How do I figure out that space? Well, this whole area is 0.5. 0.5 minus 0.4868 will give us that area right there, which corresponds there to 1.32%. Okay, so, but we're not done. Remember that this number, 1.32%, is the probability. 1.32%, right? To find out how many calls will be made in less than 15 minutes, we need to go back to the question and multiply the sample size 80 times 0.0132, and we get 1.056 calls. So hence, approximately out of 80 calls, 1 call will be responded to in less than 15 minutes. This is what we've got going on here. These questions are fun, if that's your thing. But I tell you, where you guys are going, and I'm very, very, very excited for you guys, graduating pre-health and moving on into nursing, paramedics, firefighters, vet techs, massage therapy, dental hygienist. I tell you, I really am happy for where you guys are going. And statistics, never ever lose sight of it, because where this course has taken you, you are now able to take kind of a senior level statistics and to move on from that. The whole idea of a Gaussian curve, Z-score, probabilities, the area under the curve, calculating it all, these kinds of things. you're ready, and you're going to need statistics to where you are going. And not only do you need to know about statistics, you need to know how reliable it is. And it's a lot of fun. And I'd like to say thank you to you guys for putting up with all this shenanigans here in these videos. And taking an online course is not an easy thing. Personally, my favorite, I prefer to teach this stuff in class. You get a better feel of it. But I'm proud of you guys. Your marks are doing well. Finish it off in style. Thank you so much. Take care. I will be in contact, so this isn't a complete sign off. I will post more material in the week 12 and 13 folder. Lots of practice, lots of review. We're not done yet, people. Your assignment 3 is currently live. Your quiz will go out sooner than later. And thank you so much. Take care. Bye-bye.